Hello. Today I'll be talking about section 13.3, factors affecting solubility. So there are three main categories that affect solubility. The first is solute-solvent interactions, then pressure for gaseous solutes, and then temperature. So the first part, solute-solvent interactions, the first key idea is that solubility increases with molar mass. So in this table here, you can see that as the gas's molar mass increases, then the solubility and molarity increases. So how many moles you can dissolve in liters of a solution. The next idea is with organic molecules in water. So polar organic molecules, which are typically smaller organic molecules, dissolve better in water than nonpolar molecules. And this is because hydrogen bonding increases solubility in water. So you can see in the pictures below, the hydrogen bond between two ethanol molecules is what holds them close together and can keep them in liquid form and that sort of thing. And so then it's really easy to dissolve because water also has hydrogen bonds. So you can just substitute an ethanol for a water and be able to move between them pretty easily, and it's easy to dissolve that way. The biggest idea with this section is like dissolves like. So that means that polar dissolves polar, and meaning water dissolves partial charges, and nonpolar dissolves nonpolar. So an example of this is water dissolves anything that is polar, well, almost anything, because of the hydrogen bonds and the dipole-dipole moments. It makes it a lot easier for them to become integrated and become a homogeneous mixture with the water. So then nonpolar dissolves nonpolar. So same idea with polar, where nonpolar things have a difficult time breaking the intermolecular forces between polar molecules, so they don't really mix that well. And so nonpolar molecules are often mixed with hexane. The next main idea is the pressure effects. So solubility of the gas increases in direct proportion to its partial pressure above the solution. So looking at that, so as the pressure above, so the top of the canister is the air part, as the pressure increases, so does the partial pressure of the gas above the solid. So when that increases, it's pushing more molecules into the solution, causing the solubility to increase. So as you can see, you're dissolving more things as you go to the right in the diagram. And then here's the next, and here is an equation that goes with that idea. It's called Henry's law. It's S equals Kp. S stands for the molarity or solubility of a substance. So, like how many moles per liter you can dissolve of something into a solution. K is the constant for accounting for solute-solvent interactions, and this is different for every single element and is different for depending on what you're dissolving into, like water or hexane or that sort of thing. And then P is the partial pressure of the gas above the solution, which is what you saw on the previous slide. And the third part is temperature and solubility. So solids and liquids, most are soluble if the temperature increases. Gases, it's the opposite. It decreases in solubility with increasing temperature. So here are two graphs to see that. The first one on the left, you see these are solids and liquids. So all of them except cesium sulfate, as temperature goes up, solubility increases. Whereas it's the opposite for gases. So as temperature increases, solubility decreases, which is what the graph on the right is showing. And now here is a practice problem. So these are all true or false questions, and this is problem 1335 in your book. So the higher the temperature, the more soluble most gases are in water. So this is going off of what that last graph was showing. So the answer for this one is false. Oh crap, false. And that's because, so you can see it's this graph on the right again. So as temperature increases, the solubility is actually going to decrease. Okay, and here are some practice problems. So this is question 1335 in your book, and all of these are true or false statements. So the first one is, the higher the temperature, the more soluble most gases are in water. So the answer to this is false. And this is because, looking at this last graph, you can see as temperature increases, solubility is actually going to decrease here. So the next question, the higher the temperature, the more soluble most ionic solids are in water. And this one is true, because going back to this graph on the left here, you can see that as ionic solids typically, as their temperature increases, so does their solubility. So the first one's false, the second one's true. Now, as you cool a saturated solution from a high temperature to a low temperature, solids start to crystallize out of the solution if you achieve a supersaturated solution. Now, this one is false because a supersaturated solution, it won't start to crystallize until you give it a crystalline seed to start crystallizing or agitate it in some way where the particles arrange and a crystal starts, and it builds the crystal structure and then is no longer supersaturated. So now the next question, if you take a saturated solution, raise its temperature, then you can add more solute and make the solution even more concentrated. This one is true because this is how you make supersaturated solutions, is by heating up your already saturated solution, adding more solute, and then being able to lower it back down to the temperature it was originally, where it is supersaturated now. So if you add a little crystalline structure to it, it notices the pattern and is able to turn the whole solution into crystals and reverting it back to just a normally saturated solution. Another problem similar to this is 1336. And in your book, you can also try any of the 1330s, are all related to 13.3 section. Thank you.